Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers quadratic equations. I've taken related questions from my past paper walkthroughs and given them to you here back to back. These compilation videos will give you a deep dive on topics you are still finding challenging, giving you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Circle the two roots of x minus 5, x plus 3 is equal to 0. Now, if I was wanting to imagine the graph of y equals x minus 5, x plus 3, it's a quadratic, isn't it? So it would have a parabola shape like this, and it would cross the x-axis in 0, 1 or 2 places. Here it's going to cut in 2 places. If you remember rightly, the equation of the x-axis is y is equal to 0. So basically, if you're asking when x minus 5x plus 3 is equal to 0, you're asking where these 2 points are. Okay, what value of x you're going to get there and there. You're going to get those when one or other of these brackets is 0. So either x is 5 or x is minus 3. Okay, circle the two roots, so minus 3. Question 5a, expand and simplify x plus 5, x minus 4. Okay, so we've got two brackets we're going to multiply out. So that times that, that times that, that times that, that times that. That's going to give me x squared plus 5x minus 4x minus 20. Collecting like terms in the middle, got two terms in x here. 5x take away 4x is x. So the final solution is x squared plus x minus 20. Okay, 5b says solve x minus 8, x plus 7 is equal to 0. Now, if two things multiplied together give you 0, it must mean that one of the two things was 0 to start with. So either x minus 8 is equal to 0 or x plus 7 is equal to 0. Now, if x minus 8 is equal to 0, then x is 8. And if x plus 7 is 0, then x is minus 7. Question 6, solve by factorising x squared plus 9x plus 20 is equal to 0. Okay, well, if a quadratic factorises, it's going to factorise into two brackets like that, isn't it? So I've got a x squared term at the front, so I must have an x and an x here. Now at the back of my equation I've got a plus 20. Now the 20 is going to come from multiplying this one with this one, isn't it? So I know that those two numbers must be a factor pair of 20. So what are the factor pairs of 20? I've got 1 and 20, 2 and 10, 3, nope, 4 and 5. So I've got three possible pairings, 1 and 20, 2 and 10, and 4 and 5. Now I'm looking for the combination that's going to give me that plus 9 in the middle, and the only one that's going to do that is this one here, the 4 and 5, because that adds up to 9. So it must be x plus 4, x plus 5 is equal to 0. Okay? So I've factorised, but I haven't solved. If I've got two things multiplied together to give me 0, then one of those things must have been 0, or the other thing must have been 0. Okay, in which case x must have been minus 4, or x must have been minus 5. Okay, so they're my two solutions, minus 4 and minus 5. Question 6, here is a sketch of a curve y equals x squared minus 4x minus 5. And we've got the graph. It's showing me the roots. I've got the y-intercept and I've got a point T, which I'm guessing is the turning point or the lowest point on the curve. Now it says write down the two roots of x squared minus 4x minus 5 equals 0. Now the roots are where it passes through the x-axis, and I can see there then that the roots there are at -1 and at 5. Okay, so the roots are -1 and 5. Part B says work out the coordinates of t, the turning point of the curve. Okay, now to find the turning point we need to complete the square, don't we? So I'm starting with y equals x squared minus 4x minus 5. And I'm going to rewrite it in the form of x plus or minus something all squared plus or minus something on the end. Okay, now that number that goes here is always half of this one here. So we take that one and we halve it, and that's what goes inside the bracket. So I'm going to get x minus 2 all squared. Okay, now that minus 5 that's there is still going to be on the end because we haven't dealt with that yet. But x minus 2 all squared is not a perfect replacement of x squared minus 4x. It's actually x squared minus 4x plus 4. So I need to take off 4 from that bracket to actually make it equal to the thing that's above. Okay, because at the moment this thing and this thing are not quite equal. Okay, it's minus 4 more the second thing than it is than the first thing, so I have to take it off so it balances back out again. Okay, so once I got that, I can just tidy it up. X minus 2 all squared minus 4 minus 5, that makes minus 9. Okay, so that's my equation in completed square form. So the lowest point, or the turning point, is going to be where that amount is the lowest value it can be, and that is going to be when the bracket part is equal to 0. And that occurs when x is equal to 2. So if you make x equals 2, then you get 2 minus 2 is equal to 0, and 0 squared is the lowest value that you can have, because when you square something you always get a positive number, so the very least it can be is 0, and that occurs when x is 2. And when x is 2, then the first bracket will disappear and you'll end up with y is equal to minus 9. Okay, so an easy way of thinking about it is the x value is just a negative version of that number up there, and the y value is the one on the end. Okay, that's all you get. So it's going to be at 2 minus 9 basically. So what is the coordinates of t? T has got the coordinates 2, negative 9. Question 6. The area of this rectangle can be written as ax squared plus bx minus 10. Okay, so it's a quadratic equation, isn't it? And you can see I'm going to get that because I'm going to multiply x plus c with 3x plus 2 if I want to find its area, which is definitely going to give me a quadratic. Now we need to find the values of a, b and c. So what we're going to have to do is we're going to have to multiply those two brackets together and compare it with this original equation we've been given to start with. Okay, so let's take these two. Let's take the x plus c and the 3x plus 2 and multiply them together and see what we get. So what is x plus c times 3x plus 2? Now you can use FOIL on this if you know what you're doing, or two eyebrows, a nose and a mouth. Sometimes think of it like that. If you're not so good at these, probably best to do it as a grid. So x and c and 3x and 2. And then we've got space to write all our answers in. We're less likely to forget bits of it if we do it this way. So 3x times x, 3x squared. 2 times x is 2x. 3x times c is 3cx. And then finally c times 2 is 2c. Okay? So then I've got a term in 3x squared, which I'm going to write at the start. Look, 3x squared. And then I've got two terms in x here, so I'm going to have to combine these together, aren't I? So it's going to be plus 3cx plus 2x, and then I've got a single term in, well, there's the constant term on the end, but it's got a c in it at the moment, plus 2c. Actually, I'm just going to shimmy this along a bit because I want to compare it with the other one now. So now I've got this expression, I can compare it with what we had to start with, this ax squared plus bx minus 10 business. So that's equal to ax squared plus bx minus 10. Comparing coefficients, if we compare the coefficients of x squared, now on the left hand side our coefficient of x squared has got a 3 in it, and on the right hand side it's got an a. Now if these two things are the same thing, then those two things need to be the same as well then, don't they? So this is telling me that 3 on the left must be equal to the a on the right. Okay, in other words, 3 is equal to a, so that is my value of a down there. Okay, so that's the coefficient of x squared. Now if we do the same thing, so compare the coefficients of x next, then on the left we've got two things that contribute to the coefficient of x on the left. I've got the 3c here and the 2 here, so actually I've got 3c plus 2 on the left. Those two things would add together to give you the coefficient of x on the left, and on the right we've just got the single b, so those two things must be equal to b. Now I don't know what c is yet, and I don't know what b is yet, so I've got an equation in two unknowns there at the moment. So hopefully the last one, so instead of comparing coefficients this time I'm going to compare constants. And then comparing constants, the constants on the end, on the left I've got 2c as my constant, 2c, and that must be equal to the constant on the right, the minus 10. So if 2c is minus 10, then c is going to be minus 10 divided by 2. It's minus 5 then, isn't it? So c is minus 5. And if c is minus 5, then b is going to be 3 lots of minus 5 plus 2. What's that then? Minus 15 plus 2. Isn't that minus 13? Minus 13. So then b is going to be minus 13. So a is 3, b is minus 13, c is minus 5. Question 7a, multiply out and simplify x minus 4 times x plus 5. Okay, now either you do this with FOIL, first, outside, inside, last, 2 eyebrows, a nose and a mouth, remembering to multiply all 4 things. Now if you do struggle with this, you can also do it as a grid method. So I can write x minus 4 in that direction, and then x and 5 in that direction. And then I've got like 4 spaces to help remind me there are 4 things that I need to get when I multiply this through. So x times x is x squared, x times minus 4 is minus 4x, x times 5 is 5x, and 5 times minus 4, that's negative 20, isn't it? Okay, so then we've got one term in x squared, so this is equal to x squared. We've got 2 terms in x, 5x and minus 4x, which combine together to give me x, and then I've got minus 20 on the end. Okay, so it doesn't really matter which way you do it. If you use it by FOIL, just don't forget that you're going to end up with 2 middle terms that you need to combine. If you do struggle with it, then I do recommend this grid method. People do it that way tend not to miss out terms. Okay, so if you often miss one of the terms out or get one of the terms wrong, consider doing it that way. Right, factorize x squared minus 25. This is a classic difference of 2 squares factorisation. Factorizes into 2 brackets. I'm going to get x, and the square root of 25 is 5, so I'm going to get x plus 5, x minus 5. Like I say, this is called the difference of 2 squares. Crops up a lot in papers, so you really need to recognize it and be able to do it straight off. Okay, so it's just that if you got a squared minus b squared, it factorizes into a plus b, a minus b. Okay, all the time. It's an identity. Right, let's move on. Question 8. Solve x squared equals 30.25. Now you might be tempted to just jump straight in and square root 30.25 and get your solution. But don't forget that when you square root there are 2 possible solutions, plus or minus, which is why there are 2 marks here. So root 30.25 is equal to 5.5. So x equals plus or minus 5.5. Question 11, factorise x squared plus 2x minus 24. I'm going to start with the number on the end, this 24. I'm going to think about factor pairs of 24 because I know that quadratics factorise into brackets like this. If I've got an x squared at the front, I'm going to have an x and an x to multiply together to give me my x squared. And then the numbers on here and here need to be a factor pair of 24 then, don't they? So they need to multiply together to give me 24, or minus 24 actually. So what are the factor pairs of 24? Factor pairs of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now we're aiming for 2 in the middle. We need to get a 2 in the middle. And remember, one of these has to be positive and one has to be negative. So I'm actually looking for the pair of factors which, when you add them together, is going to give you 2, bearing in mind that one is positive and one is negative. And I think it's going to be this one here then, isn't it? So if I make 4 the negative one, minus 4 and plus 6, look, then that is going to give me 2. So I'm going to say x minus 4, x plus 6 is my factorised solution then. So that's it. X minus 4, x plus 6. Question 12. Solve x squared minus x minus 12 is equal to 0. So this is a quadratic equation. It's already equal to 0, so we should be able to factorise and solve it that way. It's a non-calculator paper, which leads me to believe that we should be able to solve it by factorising. Also, they're not asking the answer to be written to 2 decimal places or anything like that. So I'm going to give a crack at factorising this then. So x times x gives me my x squared. Now the last term is minus 12. So I've got to think of factor pairs of 12 then. So I've got factor pairs of 12, 1 and 12, 2 and 6, 3 and 4. We will need to work out which one of those has got a difference of 1. It's going to be that one there, isn't it? 3 and 4. So it's a negative number, so one is positive and one is negative, and the difference is negative 1. So it's going to be the bigger one, which is going to be the positive. It's going to be the negative number, so the 4 goes there. And the smaller one of the two, it's going to be the negative one. Just double check at this point here that they do actually multiply out as you thought. So x times x is x squared, 3 times x is 3x, x times minus 4 is minus 4, it's giving you minus x in the middle, and 3 times minus 4 gives you minus 12. Okay, so I've got x plus 3 times x minus 4 is equal to 0. Now to solve it, I'm going to make each bracket equal to 0. So x plus 3 is 0, telling me that x is equal to minus 3, or x minus 4 is equal to 0, giving me that x is equal to 4. So my two solutions are x minus 3, x is equal to 4. Question 11. Factorise fully 30x squared plus 2x minus 4. Okay? So it's going to hopefully go into at least a couple of brackets, but to make things simpler, I noticed that everything is even here. So just to make the numbers smaller and therefore the number of possible factors smaller, I'm going to factorise out 2 first out of everything. So that's going to give me 2 lots of 15x squared plus x minus 2. Okay? Okay, that makes it a little bit more simple. Now let's have a look at the coefficient of x squared, 15. Now the factor pairs of 15 are going to be 1 and 15 and 3 and 5. Okay? And the other factor pairs that we're interested in is minus 2, or 2. Factor pairs of 2 is very simple, it's just 1 and 2. Okay? So that makes things pretty easy for our numbery part, but we've got 2 possibilities for our x part here. So either this factorises into 15x plus or minus something, x plus or minus something, or it factorises into 3x and 5x. It's going to be one of those pairs. Okay, Now the numbers have to be 1 and 2, and we're aiming for 1 in the middle. So either we put like 1 here, 2 here, or the other way around. That's going to be not going to work, is it? Because 15 times 2 is 30 already, and then that's going to give me 29. So that isn't going to work. Just not there. Trying the other way around. The 2 and the 1. Again, not going to get close to 1 in that case. So it's definitely not 15 and 1. Let's try 3 and 5x then. So if I put the 2 here and the 1 here, it's not going to work, is it? Because that's going to give me 10x minus 3, which is 7x in the middle. That's not going to work. But the other way around, what's that then? So if I put 1 in the first bracket and then 2 in the second bracket, then I'm going to have 3x times 2, that's 6x, and 5x. So if I make that one positive, to make that give me positive 6x, and make that one negative to give me minus 5x, then 6x minus 5x is the 1x I'm looking for then, isn't it? So then this then factorizes into 2 lots of 3x minus 1, 5x plus 2 then altogether, and that's my final answer. 2 lots of 3x minus 1, 5x plus 2. Question 13. The graph of y equals x squared plus 6x minus 2 is shown below. The roots of the equation x squared plus 6x minus 2 equals 0 are at P and Q. Calculate y when x is 1. Okay, so first up, what is the value of y when x is 1? Well, you can find the y coordinate from, if you're given the x coordinate, by just simply subbing in, can't you? So if I've got y is equal to x squared plus 6x minus 2, then when x equals 1, then I'm going to get y is equal to 1 squared plus 6 lots of 1 minus 2. So 1 squared is 1, 6 lots of 1 is 6, take away 2 is 1 plus 6 take away 2, that's 5, isn't it? So y is equal to 5, that's 5. Okay. Without solving the equation, explain why q must lie between 0 and 1. Okay, well we've already just worked out what it is at 1. At 1 we worked out that the value of the equation was 5, which is positive, isn't it? So at 1 we can see the graph is positive. At 0 we can see the graph is negative. So at somewhere between 0 and 1 it stopped being negative and started being positive, which means it crossed the axes, which means the root lies between 0 and 1. Okay, so without solving the equation, y is negative at x equals 0 and positive at x equals 1. Sign change, so must have crossed axes. Okay. Right, so explain why a method of iteration is not the most appropriate way of finding the solution to the equation. Okay, well, iteration is a useful technique, and we usually apply it when the equation we're trying to solve is difficult, or it takes a long time to solve it by methods that we know, or we don't have a method to solve it, so that we apply techniques of iteration to kind of come up with a approximation of the solution. But here we know how to solve this. We've got a quadratic formula, don't we, that we could easily use. Okay, so we wouldn't be using iteration when we've got an available method that is quick and efficient to use. Okay, so we're not going to use iteration because we have better, quicker and more efficient methods to solve, i.e. quadratic formula. You just use the quadratic formula to find it. Okay, so yeah, we're not going to use iteration when we've got a formula that we can find it exactly. Part B says the exact value of q is minus 6 plus root 44 over 2. Write minus 6 plus root 44 over 2 in the form a plus root b. Okay, so at the moment I've got like a fraction of 9 with 2 parts on the top. Now I can break that into two separate fractions. I can say that's the same thing as minus 6 over 2 plus root 44 over 2. Okay, so you can see, you can combine that. Going back the other way, we would put that over a common denominator, wouldn't we? So it's quite possible to break it up like that. Minus 6 divided by 2, well, that's just minus 3. Now, how can we kind of resolve this? Well, if I say that root 44 divided by 2 is the same thing as root 44 divided by the root of 4, because the root of 4 is 2, then I can take that second part then and write it as a single root 44 over 4 like that, and then I can divide the 4 into the 44, and I'm going to get minus 3 plus root 11. Okay, so that's equal to minus 3 plus root 11. Minus 3 plus root 11. Question 14. Use the quadratic formula to solve 5x squared plus 11x minus 2 is equal to 0. Give your answer to 2 decimal places. Okay, well, what is the quadratic formula? That says that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Then we're going to sub the values in. That's going to be my value of a. This is my b, and this is my c. Don't forget the signs belong to the letters as well. So minus b is going to be minus 11 plus or minus the square root of b squared, 11 squared, minus 4 times a, which is 5, times c, which is minus 2, all over 2 lots of 5. Okay, let's see if we can simplify that down then. That's minus 11 plus or minus. Okay, I've got 11 squared, which is 121. And I need to subtract. I've got a positive times a negative, so that's going to be negative overall. So I'm subtracting the negative, which is the same as add in. 4 times 5 is 20, times 2 is 40. Over 2 times 5, which is 10. 10. Okay, so that's minus 11 plus or minus the root of 161 over 10. So now I can just type those into my calculator to get the two answers. So x is going to be equal to negative 11. Now often calculators have a different negative button than you can't use the subtract key, you've got to use the negative one. So negative 11 plus the root of 161 divide by 10. It's going to give me x equals 0.167 to 2 decimal places, and then negative 11 minus square root of 161 divide by 10, give me minus 2.37. to 2 decimal places as requested. Question 14, find the coordinates of the turning point of the graph y equals x squared plus 6x plus 17. Now, when you are finding the turning point, what you are doing is you're completing the square run, isn't it? You want to find that kind of dip at the bottom of your parabola, and the way we do that is by completing the square. Okay, so rewriting this quadratic in completed square form, what we do is we take these first two terms and rewrite it as x plus something all squared. Now that something all squared, that is always half of this value here. So half of 6 is 3. Now if I actually multiply out x plus 3 squared, x plus 3 all squared, I'm going to get, well, it's going to be x plus 3, isn't it? Which is going to give me x squared plus 6x plus 9. I've kind of introduced 9 more than I had to start with because I'm replacing x squared plus 6x with x squared plus 6x plus 9 if I replace it like that. So I need to take off that extra 9 I've introduced. But plus, of course, I've still got this plus 17 that I haven't done anything with yet. So that's still there hanging out on the end of my, my expression there. So then all I've got to do is tidy this up a little bit. So x plus 3 all squared stays the same. I'm just going to kind of combine those two numbers at the end. 17 take away 9. That is equal to 8, isn't it? So that is plus 8. Okay, so what are the turning points then? So y is equal to x plus 3 all squared plus 8. Now the lowest value of that expression can be is, well, when you square something, it's always a positive number. And the lowest number, a square number, could be a 0. And you'll get that 0 value when x is negative 3, because negative 3 plus 3 is 0. So x equals negative 3 will give you the lowest value on the graph. And when x is negative 3, the bracket will disappear and you'll just be left with y is equal to 8. Okay, so this is going to have coordinates minus 3 and 8. Question 15. We're told that E is equal to 25 plus 2p minus pq, where E is 1 and q equals p. Work out the values of p. Well, if q is equal to p, then we can replace q with p. So let's rewrite that as 1 is equal to, because I've subbed in the value for E, which is 1, and that's 25 minus 2p minus p times p. So we'll replace q with p. So that gives me 1 is equal to 25 minus 2p minus p squared. I'm going to bring everything over to the other side, so my p squared term is positive. So that is going to give me p squared plus 2p, and 1 minus 25 is going to give me minus 24, and that's all equal to 0. All I've done is taken each term and I've moved it over the equal sign and changed the sign as it's gone over. Okay, so p squared plus 2p minus 24 is equal to 0. Can I factorise that? If I can, then I have a p and a p here. I'd be looking for factor pairs that multiply together to give me 24 and add to give me 2. So factor pairs of 24, 24 and 1, 12 and 2, 8 and 3, 6 and 4. Now, do any of those have a difference of 2? Got a feeling it's going to be that pair there, isn't it? So it's going to be p plus 6, p minus 4, give me 2 in the middle and minus 24 at the end. So equating each bracket to 0, I've got p is equal to minus 6 or p is equal to positive 4 as my two solutions. Question 15, factorise 9x squared minus 4. Okay, so I see a difference of two squareds. I see that the first thing, 9x squared, is a square, and I see that 4 is a square. So the square root of 9x squared is 3x. So I'm going to get 3x and 3x, and the square root of 4 is 2. So I'm going to get plus 2 minus 2. Okay, so 3x plus 2, 3x minus 2. Difference of two squares. You need to be able to spot it in the wild. Next one, solve by factorisation. 3x squared minus 2x minus 8 is equal to 0. Okay, so now if this factorises, I'm going to have a 3x and an x here, because 3 has only got one factor pair that works. It's prime, it's 1 and 3. So it has to be a 3x and an x. Okay, now the other number on the other end, this 8, there are possible factor pairs there, aren't there? So what are the factor pairs of 8? It could be 1 and 8, it could be 2 and 4, so there's two choices. Now, is it 1 and 8 or is it 2 and 4? I just kind of take each number and I imagine it in its place to see if it works. Okay, so if I put a 1 and an 8 here, it's definitely not going to work because 3 8s are 24 already. There's no way I'm going to get minus 2 in the middle, so it's definitely not that combo. The other way around, 8 and 1 also doesn't work because 3 taken away from 8 is 5 and not 2, so that's not going to work either. So let's try the other two pairs of numbers, the 2 and the 4. So if I make the 4 here and the 2 here, then 3x times 2 is 6x, and 4 times x is 4x. I can make a minus 2x out of that, can't I? If I make this one minus and this one plus, then minus 2 times 3x is minus 6x, and 4 times x is positive 4x. Add them together and I'm going to get minus 2x like we have in the middle here. So that's the pair that work. Okay? So really, that's what I do. I just find the list of possible ones and I keep guessing until I get the right one. For me, that is the quickest way of doing it. I've seen other people do it different ways, but that's what works for me. Okay, so I've got 3x plus 4 times x minus 2 is equal to 0. If I've got two things multiplied together equal 0, then one of the things must be 0. So 3x plus 4 could be the one that's equal to 0, in which case 3x is minus 4 and x is minus 4 thirds. Give me x is minus 4 thirds as one solution, or it could be that x minus 2 is equal to 0, in which case x is equal to 2, and that's my second solution there, x is 2. Part C says solve 2 over x minus 5 over 1 minus 3x is equal to 2. Now, you might be tempted to multiply out those brackets straight away, but hold your horses on that one. Just cross multiply in this bit here, multiplying both sides by 1 minus 3x. That is the correct move. That's going to give you 2 lots of x minus 5 as it was is equal to 2 lots of 1 minus 3x. Okay, just cross multiplying that 1 minus 3x. Now, next step, good job we didn't multiply out that bracket, because we can just cancel those off against each other. Dividing both sides by 2 just gets rid of those 2, and I don't have to multiply out the brackets after all. That's just going to give me x minus 5 is equal to 1 minus 3x. Unknowns on both sides, let's collect those together by adding 3x to both sides. That's going to give me 4x minus 5 is equal to 1. Adding 5 to both sides, so I'm going to get 4x is equal to 6, and then dividing both sides by 4, I'm going to get x equals 1.5 then, aren't I? So that's my answer, x equals 1.5, or 1.5, or 3 over 2, whichever. They're all the same. Question 16. A graph has equation y equals x squared plus px plus r, where p and r are constants. The graph passes through point 0, 4, 1, 3, and 8w. Work out the value of w. Okay. So we've got a partial equation up here. So I guess what we're going to have to do is we're going to have to work out the values of p and r to complete that equation, and once we've got the equation completed, we can use the equation with 8 to find w. Okay, so that is my plan of action, and the fact that we've got 2 coordinates I think means we can form 2 equations in p and r that we can then go on to solve. Okay, so that's what we're going to do. We're going to take the first coordinate, the first pair of coordinates first. So let's take this one here. So from the first coordinate, when x is 0, then y is going to be 4 then, isn't it? Because 0, 4 is a coordinate. So subbing both those numbers into the equation, that means 4 is equal to 0 squared plus p lots of 0 plus r. Okay, in other words, oh, p disappears, I'm just left with r and 4, aren't I? So that implies that r equals 4. Okay, so I've got 4r already. And then when x equals 1, taking the second coordinate, when x is 1, then y is 3. So that tells me then that 3 is equal to x squared, 1 squared, plus p lots of x, p lots of 1, that's just p, plus r, which we know is now 4. Okay, so I'm going to sub that in as well. So I've got 3 equals 1 squared plus p plus 4. So taking everything to the other side, 3 take away 1 take away 4, that's going to be minus 2. So p is going to be equal to minus 2. Okay, so now I know the values of p and r. I can say therefore equation is y equals x squared plus p, which we found to be minus 2. So that's actually minus, isn't it? So x squared minus 2x plus 4. That's my complete equation. Okay. And then finally, I'm going to take this last coordinate here, x, 8 and w. So I'm going to find out what w is now. So when x equals 8, y is equal to w. So then w equals x squared, 8 squared, plus, sorry, minus now, isn't it? Minus 2 lots of 8 plus 4. Okay, so what's that then? W is 8 squared, which is 64, minus 16 plus 4. So W is 64 minus 16 plus 4. Well, 64 plus 4 is 68, minus 16 is 58, 52. So then W, I guess, is equal to 52. Okay. Question 16. Frankie sketches this quadratic graph. Frankie says the y-intercept is 15. Part A says show what Frankie says could be correct. Okay. Well, we can see clearly the roots of this quadratic. We've got minus 3 over here, and we've got 5 over here. Okay. So given that the roots are x equals minus 3 and x equals 5, normally we get these from the brackets after we've factorised the quadratic, haven't I? So that would mean that I had a bracket that was like x plus 3, and I'd have a bracket that was x minus 5, but it's more likely to be 5 minus x in this one because I've got a frowning parabola. I've got one that's upside down. So the x squared term is going to be negative. So rather than having x minus 5 here, most likely that second bracket is going to be 5 minus x. And that comes from the fact that that's equal to 0. Okay, so therefore equation could be of form y is equal to x plus 3, 5 minus x. Now if I multiply that out, I'm going to get minus x squared plus 5x minus 3x plus 15. In other words, I'm going to get minus x squared plus 2x plus 15. Okay, so this here then on the end, this number on the end is the y-intercept, isn't it? Okay, just as it is on y equals mx plus c, the constant on the end is the y-intercept. Another way of thinking about it is what's the value when x is 0? So in other words, when x is equal to 0, then y is going to be 0 squared plus 2 lots of 0 plus 15. In other words, y is equal to 15. Okay, so that's the other way of thinking about it. Either way, I've got a y-intercept of 15 there, haven't I? Okay, so that's my reasoning for the first part of the question. Now explain why Frankie says Frankie says it might not be correct. Well, it could be any multiple of y equals x plus 3 x 5 minus x. For example, I could have y is equal to 2 lots of x plus 3 5 minus x, which have the same roots but a different y-intercept. In this case, the intercept would be 30. Okay, so yeah, so there we go. So it could be any multiple of that. So any number in front of it would give you like it'd be like a stretch version of that graph, wouldn't it? It'd go through the same points, but it'd be kind of like taller if you multiplied it through by a number. Question 17. Charlie is making some wooden frames. Charlie has a strip of wood which is 1.6 meters long and 2 centimeters wide. Each frame will be made from 4 pieces of wood cut from the strip to form a rectangle as shown below. So the width of each frame is x centimeters. The length of each frame is 2x centimeters. the area enclosed by each frame must be 96 centimeters squared. Work out the maximum number of frames Charlie can make from 1.6 meters length of wood. You must show your working. Okay, this is a nice problem. Right, so what are the dimensions of this shape? It's 2x and x, and it has an internal area of 96 centimeters squared. Okay, that's interesting. So then presumably this distance from here to here then is going to be x minus 2 and 2, isn't it? So x minus 4 in that direction. And then from here to here, that's going to be 2x minus 2, 4 as well, isn't it? So that's going to be 2x minus 4, okay? And then those two things multiply together, so x minus 4 times 2x minus 4, that is going to be equal to the area I've been given then, isn't it, of 96, okay? Now I want to solve this and work out what x is. So I think what I'm going to do is I'm going to multiply it all out first and see if I can reform it into another quadratic that I can solve. Okay, so just doing FOIL on here, first outside, inside, last. I'm going to get 2x squared minus 4x minus 8x plus 16, and that is equal to 96. So collecting like terms together, minus 4x minus 8x is minus 12x plus 16. I'm going to take the 96 over to the other side so it becomes minus 16, take away 96. That is minus 80, isn't it? Okay, and that's all equal to 0. Right, now notice that I've got multiples of 2 everywhere. So before I factorise, I'm just going to simplify this by dividing everything by 2. So I'm going to get x squared minus 6x minus 40 is equal to 0. Okay, that should make factorising a little bit easier. So I'm going to have x and x here. Factor pairs of 40. Right, what goes into 40? 1 and 40, 2 and 20, 3, nope, 4 and 10, 5, yep, 5 and 6. 5 and 8, sorry, 6, note, 7, no. So that's all the factor pairs. Okay, now I'm looking for a factor pair that has a difference of negative 6. Okay, so I'm thinking it must be this pair here then. So if I have like plus 4 minus 10, that's going to give me minus 6 in the middle. So plus 4 minus 10 in there. Now that gives me two solutions for x. X equals minus 4, x equals 10. Okay, now so you might be thinking, is there two solutions to this problem? But no, there's not now, because x minus 4 is a solution to the particular equation I was looking at, but it's not a solution to the problem, because here x is a length, and unless we're living in some sort of alternate reality, we can't have a negative length. So that one is not a solution. Not a solution. Okay? Can't have a negative length here. So that means that x equals 10 is the length. So that means that this longer piece of wood is going to be 2 lots of 10. It's going to be 20, isn't it? So I need one piece of wood which is 20. Well, I actually need 2 of those because it's the top and the bottom of the frame. And what's the shorter one then? The shorter one is going to be x10, take away 2, take away 2. So that's going to be a 6 centimeter frame then, isn't it? And I need 2 of those. Okay, so total required is going to be 20 times 2 plus 6 times 2, which is 40 and 12 is 52 centimeters. Okay, now how much wood have I got? I've got 1.6 meters, which in centimeters, that's 160 centimeters, isn't it? Okay, so how many frames can I make? Number of frames is going to be the 160 centimeters I've got divided by the length 52. How many times does 52 go into 160? Well, it's roughly 3, isn't it? It's 3 with a bit left over. 3 remainder. 52 times 3 is 156. So it's going to be another 4 centimeters wasted, isn't it? But it roughly goes in 3 times, okay, with a little bit to spare. So we can make 3 frames from that length of wood. Okay. Question 18a. Write x multiplied by 3x minus 9 equals 4 in the form of ax squared plus bx plus c is equal to 0, where a, b, and c are integers. Okay, so let's start by multiplying out the brackets. So x times 3x is going to give me 3x squared. X times negative 9 is going to give me negative 9x. And that's equal to 4. So then subtracting 4 from both sides, that's going to leave me with 3x squared minus 9x minus 4 is equal to 0 as required. And part B says solve x plus 3x. X times 3x minus 9 is equal to 4. And give your answers to 2 decimal places. Well, we're going to use our rearrangement from part A, aren't we? So I'm just going to rewrite down what we just had. So we've got 3x squared minus 9x minus 4 is equal to 0. Okay. Now, give me the answer to 2 decimal places. That's a really big hint to tell me that I'm going to be using the quadratic formula here. So I just need to extract my coefficients here for A, B, and C. A is the coefficient of x squared. It's going to be 3. B is the coefficient of x, it's going to be minus 9, and C is my constant on the end, which is negative 4. Okay, once I know A, B, and C, I can sub those into the quadratic formula, which tells me that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's sub in our values of a, b, and c into that. So I've got minus b minus negative 9 is plus or minus the square of negative 9 minus 4 times a, which is 3, times c, which is minus 4. Now I always sub in brackets. I just think it helps dealing with all the negatives and things that come out of these things. All over 2a, which is 3. Okay, and let's see if we can tidy this up. Negative minus negative 9, that is going to be positive 9, isn't it? So that negative is going to make a plus. 9 plus or minus, what's the root there then? So minus 9 squared, negative 9 squared, negative 9 times negative 9 is positive 81. And I've got minus 4 times 3 times negative 4. And again, my two negatives there are going to make a positive, so it's going to become a plus. 4 times 3 is 12, 12 times 4 is 48, isn't it? So it's 81 plus 48 all over 2 lots of 3, all over 6. Okay, so what's 81 plus 48? It's 129, isn't it? So that is equal to 9 plus or minus root of 128 all over 6. Okay, almost there. So I'm going to get one solution when I add the root 128, and I'm going to get the second solution when I subtract it. So let's put the add one in first. I can just type it in now to the calculator in the form that it's in. 9 plus root 128 all divided by 6. That will tell me one of my values of x. I make that 3.3856, which I'm going to round up to 3.39. So 3.39. That's one of my values. The second value I'm going to get, instead of adding, I'm going to subtract. So I'm just going to press the back button so I can go back to the previous calculation. I'll go through and change that plus to a minus and press enter again. That's going to give me a second solution of x equals negative 0.39 rounded off. Okay, and that's my second solution. All done. Okay, question 18. Circle the two roots of 2x plus 3 times 5x minus 2 is equal to 0. Well, you get the roots when the equation is equal to 0, and those two things multiplied together gives you 0. Must mean one or other of them was 0 to start with. So either this first bracket here is equal to 0, So maybe 2x plus 3 is equal to 0, which means that 2x is minus 3, which means that x is minus 3 over 2. So that one there is a root. Or this bracket here is equal to 0. So 5x minus 2 is equal to 0. So 5x is 2x is equal to 2/5. So that one there is the other root. Question 18, solve this quadratic by factorisation. Now I haven't got everything on one side yet, so I'm going to move everything over to the left hand side first of all. So subtracting 5x from both sides, I'm going to get 2x squared minus 11x, and then adding 3 to both sides, my minus 24 is going to change into minus 21. So then that is going to be equal to 0. Just moving this over to this side and this over to this side. Change sides, change signs. So yeah, so I'm going to get 2x squared minus 11x minus 21 is equal to 0. Now, to factorise it, I start off looking at this number on the end, the minus 21, and think, well, what factor pairs does 21 have? 21 has factor pairs 1 and 21, or note 2, note 3, 3 and 7, 4 note, 5 note, 6 note. That's all of them, isn't it? You've just got 2 choices there, 1 and 21 and 3 and 7. Okay? Now, so I'm going to have 2 brackets that this factorises into. Okay, now because I've got a 2x at the beginning, I'm going to have a 2x and an x here, so that 2x times x gives me 2x squared. Now when I need to pick a pair of numbers, either 1 and 21 and 3 and 7, I'm going to put in these brackets and I'm going to try and get minus 11 in the middle. Okay, sometimes it's a matter of trial and improvement. You know, you try a pair until you get one that works. So for instance, if I put the 1 and 21 in here, that's not going to work, is it? Because I'm going to get 2 lots of 21, which is 42, and 1 lot of x, which is x, and I can't make minus 11 out of that. That's not going to work. Okay, now if I switch them around, so if I put the 21 this side and the 1 on this side, that's also not going to work, because 2 times 1 is 2. Taking that away from 21 is not going to give me 11 there, so that doesn't work either. So I'm going to try the other pair of numbers. I'm going to try 3 and 7. Now if I put the 3 here and the 7 here, then I've got the 2x times 7. That's going to give me 14x, and then the 3 times the x is going to give me 3x. I can make 11x out of that, can't I? If this was minus, that would give me minus 14x, and so if this is plus, minus 14x plus 3x is going to be minus 11x in the middle then, isn't it? So that works. It's going to be that way around. Okay, so I just, like I say, I just work out what my possible pairs are, and I put them in until I find a pair that actually fits with the middle term. Okay, so I've got 2x plus 3, x minus 7 is equal to 0. I now want to solve this. Now I've factorised it, I can go on to solve it. If you've got 2 brackets multiplied together to give you 0, that means one of the brackets must be equal to 0. So either 2x plus 3 is equal to 0, or the other bracket is equal to 0. X minus 7 is equal to 0. Okay? Now if x minus 7 is equal to 0, that's easy. That's just x is 7, so that's one solution. The other one, 2x plus 3 is equal to 0. Take the 3 to the other side. I'm going to get 2x is equal to minus 3, and then divide both sides by 2. I'm going to get x equals minus 3 over 2, and that's going to be my second solution then. So minus 3 over 2 adds 7 are my 2 solutions. Question 18a, part 1, write x squared plus 4x minus 16 in the form x plus a all squared minus b. Okay, so this is in a quadratic expanded form. This one is in what we call the completed square form. It's fairly easy to convert one from the other. What we need to do is we take the coefficient of x here and we halve it. So the coefficient of x is 4, half of that is 2. So we're going to replace x squared plus 4x with x plus 2 all squared. Now x plus 2 all squared is x squared plus 4x plus 4. So we're actually replacing x squared plus 4x with 4 more than we should. So we need to take off a square of 2, which is 4. And then we already had minus 16 there to start with. So then we're going to group those together. So we're going to get x plus 2 all squared. Minus 4 minus 16 is minus 20. Okay, so that's how it goes. You start by looking at the coefficient of x. In this case, it was 4. We halve it. That's the number that appears there. You have to remember that x plus 2 all squared is not a perfect replacement for x squared plus 4x. It's 4 more than you should have. So that is why we then take off that square of 2, which is 4, and then we combine that minus 4 with the 16 to give us minus 20. Okay, so that's what we've done. Solve the equation x squared plus 4x minus 16 equals 0. Give your answer in surd form as simply as possible. Okay. Now, I could go and use the formula to do this, but because I've already gone to the trouble of completing the square above, I'm going to rewrite x squared plus 4x minus 16 in the completed square form that I just found. So I'm going to replace x squared plus 4x minus 16 with its completed square form. X plus 2 all squared. That's a rubbish looking 2. Let's try that again. X plus 2 all squared minus 20, and that is equal to 0. Okay. Right, the reason I'm doing that is because I can then just solve this by rearranging rather than, extracting a, b, and c and subbing it into that really awful formula. I'm just going to rearrange this to make x a subject. So first off, I've got this minus 20 on the end. So if I add 20 to both sides, that will pop over to the other side of the equal sign then, won't it? So that's going to give me x plus 2 all squared equals 20. The next thing is to get rid of this square sign here. Now the opposite of squaring is square rooting. So if I square root both sides, the square root of x plus 2 all squared, they're opposite processes. That's just going to leave me with x plus 2 on the left. And then I need to square root this side as well, don't I? So that's going to leave me with x plus 2 all squared is equal to 20. Now, actually, when you square root something like that, there's actually 2 possible solutions it can be. It could actually be positive root 20 or negative root 20. So it should actually be plus or minus root 20 there. The last thing I need to do here is to deal with this plus 2 over here. I just need to subtract 2 from both sides, and I have the result of kind of moving it over the equal sign. Okay, so it'll pop over there. So subtracting 2 from both sides is going to give me x equals negative 2, because plus 2 on one side becomes negative 2 on the other, plus or minus the root of 20. Okay, so you can see we get straight into the simplified version of the quadratic formula. So it's actually easier to do it this way than extracting a, b, and c and subbing it in, I think. Okay, so give your answer in surd form as simply as possible. Right, let's just have a quick look at this bit on the end, root 20. Is that the simplest way we can write that surd, root 20? Now, if you think 20 has got a square factor, it's got a factor of 4, isn't it? 20 is 4 times 5. I can break up root 20 into root 4 times root 5, and the root of 4 is 2. So I can simplify that down a little bit and say that is the same thing as 2 root 5, okay? And that really is as simple as it gets. I can't really simplify it any further than that. Now, I suppose you could break this up into 2 distinct roots. You could say x was negative 2 plus 2 root 5, and x is equal to minus 2 subtract 2 root 5, but I don't actually think that's going to simplify it any more than it already is. I think it's quite neatly stated. Like that, I don't think I need to split it up into 2 answers. Okay, so I'm just going to leave it like that. X equals negative 2 plus or minus 2 root 5. Part B says, sketch the graph of y showing clearly the coordinates of any turning points. Right, now sketch does not mean plot. I don't have to find like a table of values and carefully plot these points. I just need to show the general shape and then kind of mark on my diagram any features like intercepts and turning points that crop up. Okay, now we already know that this is a quadratic because it was given in the form y is equal to ax squared plus bx plus c. Can't remember what it was now. What was it? Y equals x squared plus 4x minus 16, wasn't it? Okay, so we already know it's a quadratic, and we also know because this term here is positive, it's a smiley quadratic. In other words, it's a U-shaped parabola. It's going to look like that. Okay. The next thing we did was we completed the square, and we found that we could rewrite y as x plus 2 all squared minus 20, and from that we can read out the turning point. This value, or this expression, is at its minimum when this squared part at the front is equal to 0. Because when you square something, the least value it can possibly be is 0. Any other value, negative or positive, you square it, it's going to become bigger than that. So what value of x makes this bracket 0? It's going to be x equals minus 2. So the x coordinate of the turning point is negative 2. When x is negative 2, that first bracket will disappear. Negative 2 plus 2 is 0. 0 squared is 0. And you'll end up with y is equal to negative 20. So that is my turning point then. So this has a turning point at negative 2, negative 20. So that's that point there, isn't it? The lowest point on the curve. Okay, and we also know the roots of this equation. We went on to find that x equals minus 2 plus or minus, it was 2 root 5, wasn't it? 2 root 5 or root 20. Okay, so how big is the root of 20? Well, we know the root of 16 is 4 and the root of 25 is 5. So the root of 20, or 2 root 5, is going to be somewhere between 4 and 5. So we think that this bit here is about 4.5, something like that. Okay, so this graph is going to have roots at round about minus, well, negative 2 subtract 4.5 would be about minus 6.5. And negative 2 plus 4.5 would be 2.5, wouldn't it? Okay, now these are just estimates, so I can just kind of get a sense of the size of my graph that I need to draw. Okay, so I'm going to have a root somewhere down here about minus 6.5, just trying to work it out relative to each other. So I'm going to have another root somewhere there in the positive 2.5 area. Okay, there or thereabouts. Okay, so I need to draw my parabola that it passes through those 2 points. So let's do that then. Let's draw that parabola in. So the turning point is going to be somewhere around here to the left of the axis, isn't it? And then it's going to go up like that, back through that point there. Okay, so if it's roughly parabolic, I think that's fine. You can obviously have a line of symmetry running down the middle. Okay, and then this lowest point on the curve, that is the point negative 2, negative 20. And I think we need to mark that coordinate on, negative 2, negative 20. Okay, that's our turning point. Okay, and I think we also need to label these intercepts as well. Now we said this one on the left was around about minus 6.5, and that was just to really work out where on the line it is. Exactly what it is negative 2 subtract 2 root 5. So this one over here is negative 2 subtract 2 root 5. Oops. Negative 2 subtract 2 root 5. And this one on the other side is negative 2 plus 2 root 5. Okay, so I'm going to write the exact values on there. Okay, and that's my sketch. It's got the general shape of a parabola. It's a U-shaped parabola, not a frowny one. It's a smiley one. I've got the turning point marked at minus 2, minus 20. And I've got my two roots, negative 2 minus 2 root 5 and negative 2 plus 2 root 5. Okay, so I've got all the information on there. That's a good sketch. Let's move on. Question 18, by completing the square, prove that x squared plus 6x plus 13 is always positive. Okay, so when you're completing the square, you take that coefficient of x there and you halve it. So half of 6 is 3. So inside my bracket, I'm going to get x plus 3, half of the coefficient of x. So x plus 3 squared. Now, if you multiply out x plus 3, you're going to get x squared plus 6x plus 9. So you need to take that extra 9 away that you just introduced. Plus I've already got the 13 there from before. So then just tidying that up then, that's going to be x plus 3 all squared minus 9 plus 13 is plus 4. Okay. So what's the turning point of this graph then? So the turning point is going to be the coordinate, well, what value of x makes x plus 3 equal to 0? It's minus 3, isn't it? So x must be minus 3. And when x is minus 3, I'm going to get minus 3 plus 3 is 0, and 0 plus 4 is just 4. So the turning point there is at minus 3, 4. So if I was going to sketch this quadratic, I would have a graph that looks like minus 3, 4. There's my point, minus 3, 4. It's a smiley quadratic. So it's going to come down, that's going to be my lowest point, and it's going to go back up again. Can you see the graph wholly exists above the x-axis? So therefore it is positive for all values of x. So that's what I'm just going to finish this off. Graph lies wholly above the x-axis, so is positive for all values of x. There we go. Question 18a. By factorising, find the roots of y equals x squared plus 18x plus 77. Okay, so I need to factorise factors of 77. What are they then? Let's see if we can work out some factor pairs of 77. So we've got 1 and 77. What other numbers go into 7? I suppose 7 does. 7 and 11. Is that it? I can't think of any more. 2 doesn't. 3 doesn't. 4 doesn't. 5 doesn't. 6 doesn't. 7 doesn't. 14? No, 14 doesn't. I think it's just those two. 1 and 77 and 7 and 11. I think it's going to be 7 and 11 because 7 and 11 add up to 18, which is the middle term. So I think we're going to go for this pair here. 7 and 11. So x plus 7, x plus 11, like that. Okay? So if that is the case, then the roots occur when y is equal to 0. It's where it crosses the x-axis, which is the line y is equal to 0. So when y is equal to 0, then x plus 7, x plus 11 is equal to 0, in which case x is equal to minus 7 and x is equal to minus 11. Okay, so they're my roots. Minus 7, minus 11. Part B says, write y equals x squared plus 18x plus 77 in the form y equals x plus a all squared minus b. Now that is the completed square form, isn't it? Now this number here is always half of the coefficient of that term there. So it's going to go into something that looks like x plus 9 all squared. Okay. Now if we're going to replace, if we're going to do the difference, but if we're going to do that, x plus 9 all squared actually gives us x squared plus 18x plus 81. So we've introduced 81 more than we should have, so we need to take that one away again. 81 is the square of the 9. So after you halve the 18 you get 9. It's x plus 9 all squared minus the square of 9, which is 81. But remember we had the 77 that was there already, and we've still got that 77, so plus 77 in there. So just tidying that up then, I've got y is equal to x plus 9 all squared and minus 81 plus 77. Those two numbers have got a difference of 4, haven't they? So it's going to be minus 4. So y is equal to x plus 9 all squared minus 4. Right, part 2 says write down the coordinates of the turning points of the graph. Well, we just worked out that the completed square form was y equals x plus 9 all squared minus 4. So the turning point of this graph is the lowest possible value it can be, and that occurs when this part here is equal to 0, because any number squared is a positive number. So the smallest value a square can be is when it's 0. So what value of x makes that bracket equal to 0? It's going to be x is equal to minus 9. So when you add 9 to it, you get 0, and 0 squared is 0. Okay? And when x is minus 9, and that bracket becomes 0, then y is going to be equal to what's left, because the bracket is going to be 0. So y is equal to minus 4. So y is equal to minus 4. So x is minus 9, y is minus 4. Job done. Question 18. Ryan is using the quadratic formula to solve an equation of the form ax squared plus bx plus c is equal to 0. After substituting the values into the quadratic formula, he gets x equals minus 3 plus or minus 3 root 5 over 2. Find a possible values, or find a set of possible values for a, b, and c. Okay, so if you remember, the quadratic formula should be the form x equals minus b plus or minus the root of b squared minus 4ac over 2a. Okay, so we can work out a little bit about a, b, and c by comparing what we've got over here in this with the quadratic formula, and then seeing if we can match anything up. Now, first off, I can see that minus 3 at the beginning matches with the minus b at the front here. Okay, so that tells me that b could be 3. Okay, and I can see that the 2 down here matches with the 2a, which would imply to me that a is equal to 1. So b squared minus 4ac, we know that should be 3 root 5. So comparing the root of b squared minus 4ac, and we think that is going to be 3 root 5. But I know some of these values, so subbing in what I know, b is 3, so b squared is going to be 9. 4ac, well I know a is 1, so 4a is just 4, so it's going to be 4c. 9 minus 4c rooted is going to be 3 root 5. Okay, let's just get rid of the square root by squaring both sides. So 9 minus 4c is equal to, right, 3 squared is 9, root 5 squared is 5, 9 times 5 is 45. Okay, so what does that make c then? I've got rearranging, moving the 4c over to this side and the 45 over to this side. I'm going to get 9 minus 45 is equal to 4c. 9 minus 45, negative 36, divided by 4, that's negative 9, isn't it? C is 9, negative 9. Okay, so that's one possible value. A is 1, B is 3, C is negative 9. Okay. Explain why there are other sets of possible values of A, B, and C. Well, that comes down to the fact that, you know, what we're doing when we're solving a quadratic equation is we're finding roots, aren't we? So let's say we found these two roots. Okay, now that could be this parabola that fits through those, but there are other parabolas that fits through the same root. You know, you could have a kind of a shallower one, or you could have a kind of a steeper one. Okay, so there's lots of different parabolas that could go through the same two roots. So just knowing the roots is not enough to kind of uniquely identify the parabola. So what's my answer going to be? There are many parabolas that would fit through the same two roots. Question 19a, write x squared minus 10x plus 22 in the form x minus a squared all minus b. So this is what we call completed square form. It's fairly easy to rewrite a quadratic this way. What you need to do is we take this coefficient minus 10 and we halve it and we write that inside the bracket. So x minus half of negative 10, which is negative 5 squared, and the square goes to here. Now we then need to take off a square of this number, because if I'm replacing x squared minus 10x with x minus 5 all squared, I've actually introduced 25 more than I should have. If you try and multiply this out, you should see that you get x squared minus 10x plus 25. So we need to take that extra 25 off. Plus we still had the plus 22 from earlier. So just add that on to the end. Okay, then the next thing you have to do is just tidy up the end part. So the minus 22 and the plus, the minus 25 and the plus 22 make negative 3. Okay, so in complete square form, that is x minus 5 all squared minus 3. Now part B says sketch the graph of y equals x squared minus 10x plus 22. Show clearly the coordinates of any turning points and the value of the y-intercepts. Okay, so we already know that y can be rewritten in the form x minus 5 all squared minus 3. Okay, which means that it has a turning point. We can read that out of the completed square form, because x squared minus 5 all squared minus 3 is at its least when this bracket part is 0. And the reason for that is, if you square a positive number, you get a positive number. If you square a negative number, you get a positive number. So the smallest number a square can be is 0. So what value of x makes that bracket 0? 5, doesn't it? Because 5 minus 5 is 0. So x must be 5. So that's the x coordinate. And if x is 5, then I've got 0 squared minus 3, so which means that 0 minus 3 is the y coordinate. So this has a turning point at 5 minus 3. So let's just kind of plot that on our sketch. So 5 along and 3 down. So it doesn't have to be perfect, but you kind of, just pick your point somewhere on your diagram like that. So that's the point 5 minus 3. That's my turning point. Now we also have some intercepts to draw. The y-intercepts we can get from the c part of your equation, isn't it? This part here, the number on the end. So the y-intercept is going to be 22. Okay, so I don't know, somewhere up here, 22. And now if we wanted to work out where the x-intercepts, or the roots, we'd have to factorize and solve that, but it doesn't want those, so I'm not going to bother doing it then. Okay, I thought it might want like those roots like there. Let me just budge that along a bit so it looks like it's at the bottom of the curve. Yeah, so that's 5 minus 3. So I've already marked it on. I just cheated a little bit because I missed my original point, but who cares? And then 22 is at the top there. Yeah, so like I say, these points down here are called the roots, and we get those by factorising and solving our equation, but they didn't want them for this question. It just asked for the y-intercept and the turning point, which we've provided. Question 19a, write x squared minus 8x plus 9 in the form of x minus a all squared minus b. In other words, we're being asked to complete the square here, aren't we? So we've got x squared minus 8x plus 9. Now when we're completing the square, it's the first two terms that we replace. The other one kind of gets added on to the end, okay? And the way we do it is we replace those first two terms by x minus something all squared, and that's something that at the end here is always half of this digit here. So whatever that is, we halve it and then we write underneath like that. So I'm going to be replacing x squared minus 8x with x minus 4 all squared. Now if you actually multiply out x minus 4 all squared, you'll see that you actually get x squared minus 8x plus 16. So by replacing what we had with that, we've actually introduced 16 more into our sum than we should have. So then we need to take that 16 away. Okay, so we've replaced x squared minus 8x with x minus 4 all squared minus 16. That is the replacement we're making. but remember we had plus 9 on the end. It's still there, so we need to then combine those two things together. Okay, so then that is going to give me x minus 4 all squared minus 16 plus 9. That comes to minus 7 then, doesn't it? Okay, so then that is going to be, yeah, that's my answer, x minus 4 all squared minus 7. Okay, use your answer to part A to solve x squared minus 8x plus 9 is equal to 0. Given your answer in exact form, you must show your working. Okay, now there are 3 different ways of solving an equation, a quadratic equation: factorising, formula, and by completing the square. So you might be less familiar with completing the square, but it's actually where the formula derives from, and it's really easy to solve. Once you've got it in completed square, like a form like this, it's really easy to go on and solve it. Just adding 7 to both sides. You can see I'm going to get x minus 4 all squared is equal to 7, because they're going to cancel. Okay, and then taking the square root of both sides, if I square root that and I square root that, I'm going to get the square root of x minus 4 all squared is just going to be x minus 4. So that's going to be equal to root 7. Well, it's actually plus or minus root 7, because when you square root something, there's 2 possible solutions. And then finally, adding 4 to both sides, and we're going to end up with x equals 4 plus or minus root 7. So what are my 2 exact forms? So I'm going to get 4 plus root 7 is one solution, and 4 minus root 7 is my other solution. Question 19. Using the quadratic formula or otherwise, solve 3x squared plus x minus 5 equals 0. Okay, now if they're suggesting that we use the quadratic formula, even though they say you could do it another way, it's usually going to be the easiest way to do it. So I'm just going to launch straight into the quadratic formula and not worry about any other ways of doing it. Okay, so for the quadratic formula, we need to read out the coefficients of our values, our quadratic here. 3 is the coefficient of x squared, that's our value of a. 1 is the coefficient of x, which is our b value, and that is our c value there, isn't it? So a equals 3, b equals 1, c equals minus 5, okay, from the equation. So writing out the quadratic formula, our value x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Can you remember this yet? You really need to. Okay, just try and memorize it. I find it quite easy now. I've written it down so many times. Right, so let's just sub in the values then. So our b value, look, is 1. That's going to go there. Well, it's minus b. So minus 1 plus or minus the square root of 1 squared minus 4 times a, which is 3, times c, which is minus 5. Okay, so I'm just subbing in the values for b, a and c into the equation, and then a on the bottom like that. Oh, I haven't done the bottom yet. So down here I'm going to get 2 lots of a, 2 lots of 3. Okay, so now I could just type this all into the calculator straight away, but I actually find it easier to resolve some of it first. Personally, I'm quite good at doing maths, so I'm less likely to make a mathematical error using my mental maths than I am probably a keying error on the calculator, so I tend to try and tidy it up as much as possible first. So 1 squared minus 4 times 3 times minus 5. 4 times 3 is 12, times minus 5 is 60. Minus minus is plus, so it's 1 plus 60. That's going to give me 61 under the square root, all divided by 6. Okay, so when I kind of got it to this stage, then it's much easier to type into the calculator. So minus 1 plus root 61 over 6, and minus 1 minus root 61 over 6. So let's do the first one first. So negative, I'm going to use the fraction key so I can write it down like it is on the page. So negative 1 plus the root of 61 over 6. Okay, so my first answer is 1.14 rounded off to 3 significant figures, or and now I need to do it again with the minus rather than the plus. I'm just going to press the back key on the calculator. I'm going to go back to where the plus is. I'm going to delete it, and I'm going to put a minus sign in as instead. I think that's the quickest way of doing it, and that comes out to be minus 1.47, rounded off, minus 1.47. Okay, so there are my two answers, 1.14 or minus 1.47. Question 20. The only solution of x squared plus bx plus c is equal to 0 is x equals minus 15. Work out the values of b and c. Okay. Now, normally, when you've got a quadratic, you're going to get two solutions because it kind of goes through the x-axis and it comes back again like that. So you'll get one solution, another solution. Okay. Now, sometimes your curve goes over the x-axis and there's no solution. And there is a case where it just kind of touches the x-axis there. So that is where you get one solution, okay, where it just touches. And that occurs when we have what's called a repeated root, okay? So if you think about when you factorize a quadratic into two brackets, like this, if this was a and this was b, then it would factorize into x minus a, x minus b, and that would be the roots. This one wouldn't factorize because it doesn't have any roots. This one, if it's got one root, then it's going to be like x minus a, x minus a. We call it a repeated root, okay? So here, we haven't got a, we've got 15, well, minus 15. So that means that x squared plus bx plus c equals 0 factorizes into x plus 15, x plus 15. Okay, has to, because then it's a repeated root and that root is equal to minus 15. Okay, so then if we then multiply that back out again, if I just multiply this out, okay, what do I get? I get x squared plus 15x plus 15x plus 15 times 15. What's that? Ooh, that's some beans. 225. Right, so then that's x squared plus 15x plus 15x plus 225, which is x squared plus 30x plus 225. Okay, so if I compare that with what I've got up there then, so the b part then needs to be that one there, and then the c part is going to be that one there then. So b is going to be 30 and c is going to be 225. Question 20, part A. Write x squared minus 6x plus 11 in the form x minus a all squared plus b, which is the completed square form, isn't it? So let's do that. X squared minus 6x plus 11. Now, it's going to go into a bracket with an x here and a square here. Now, the number that goes in here is always half of this one. So it's going to be minus 3, x minus 3 all squared. Now, if you multiply that x squared minus 3 all squared, you'd get x squared minus 6x plus 9. So we've introduced 9 more than we had to start with. So we need to take that 9 away. And we've still got the 11 there from earlier. Okay, so just tidying this up, I'm going to get x minus 3 all squared minus 9 plus 11 is plus 2. Part B says sketch the graph of y equals x squared minus 6x plus 11. Show clearly the coordinates of any turning points. Okay, well, we've already found where the turning point should be, haven't we? Because we know already that this one can be rewritten in the form y is equal to x minus 3 all squared plus 2. Now, this will be at its minimum value when this part here is at 0. So that's going to happen at the point, well, what value of x makes that bracket 0? It's 3. And then if that bracket, if x equals 3 and that bracket is 0, then the y coordinate is going to be 2, isn't it? So it's going to have a minimum value at 3, 2. So where's 3, 2? So 3, 2. So it's going to like have a minimum value here, isn't it? Okay. So it's going to be a parabola. It's going to have that as its minimum value. So let's kind of draw a parabola in. There's going to be no roots because it doesn't cross the x-axis, but we should probably say what the y-intercept is here. Okay, what's that point there? It's going to be this constant on the end here, isn't it? It's going to be 11. So that point's going to be 11. This is going to be the point 3, 2, and I think that's all the information we need to put on our graph. Okay, job done. Right, question 21. Solve 5x squared equals 10x plus 4. So I've got a quadratic equation. Now I'm told to give my answer to 2 decimal places. So this is immediately telling me that this is going to be use of formula rather than factorising. So let's take our equation 5x squared equals 10x plus 4. Rearrange it to get everything on one side. 5x squared minus 10x minus 4 is equal to 0. So then this is my value of A, this is my value of B, and this is my value of C. So A is 5, B is minus 10, and C is minus 4. Okay, so what is x then when I use the formula? X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now I just need to carefully sub into this. So minus b is minus negative 10, so minus negative 10 plus or minus the square root of negative 10 squared minus 4 lots of a, which is 5, times c, which is minus 4, all over 2 lots of a, which is 2 lots of 5. Okay, so what's that equal to? I'm going to continue down here, otherwise I'm going to run into my answer box. Negative minus 10 is positive 10, plus or minus the square root of minus 10 squared is positive 100. I've got minus times positive times negative, so that minus is going to become a plus. And 4 times 5 is 20, times 4 is 80. So I'm going to get 100 plus 80 over 10. And just tidying that up now, that is root 180 then, isn't it? So 10 plus or minus the root of 180 all divided by 10. Okay, time to reach for the calculator. So 10 plus root 180 equals, divided by 10 equals, that's 2.34. So x equals 2.34. Or if I take away instead 10, subtract the root of 180 equals, divided by 10 equals minus 0.34. So, or x equals negative 0.34. They're my 2 solutions, correct to 2 decimal places. (21b). Levy is solving 2x squared plus 5x equals 0. He uses this method. 2x squared plus 5x equals 0. Subtract 5x from both sides. 2x squared equals minus 5x. Divide both sides by x. Gives me 2x is equal to minus 5. And then divides both sides by 2. Which gives me x equals minus 2.5. Now on the surface it looks like it's a solid method, but you should never really divide through by an unknown, because you can lose values. At this point here, where he divides both sides by x, he ends up losing values. He loses a solution of x. So he's only got one answer, isn't he? And this is a quadratic. You'd normally expect 2 solutions to a quadratic equation. So evaluate his answer. I'm going to say he has lost a solution. What really you should have done here is factorize out the x. So better to factorise. So you get 2x squared plus 5x equals 0. So factorising out the x, going to get 2x plus 5 is equal to 0. So then here I've got x is equal to 0, which is my first solution, and I've got my x equals minus 5 over 2, which is the same solution as, what's his name? Levy found. Okay. (21) Express x squared minus 6x minus 15 in the form x minus a all squared minus b, where a and b are integers. Okay, so in other words, they wanted us to complete the square here. That's what this technique is called. Having a look at the first two terms to start with, we can rewrite this as a square by taking the coefficient of x and halving it. So rather than having x minus 6x, I'm going to have x minus 3. Okay, so x minus 3 all squared. If you multiplied that out, you get x squared minus 6x plus 9. So we need to take that extra 9 away that we introduced. Okay, and then what I've written down now balances with the x squared minus 6x. And then I've got minus 15 on the end that I had before. So I need to kind of add that back in. Okay, so this bit here is a replacement for the x squared minus 6x. And I had the minus 15 on the end. Okay, so then just tidying that up a little bit. Then I've got x minus 3 all squared minus 9 minus 15 is minus 24 then, isn't it? Okay, so is that in the right form? A is 3, b is 24. Seems to work, doesn't it? Okay, we're done there. Question 22, factorise fully x cubed minus 49x. Okay, well, first off, I noticed straight away that both these terms have got an x in them. So I can factorise out an x from both terms straight away. So factorising out the x, I'm going to get x, open brackets, x squared minus 49, haven't I? Okay. So I factorised it a bit, but I need to factorise it fully. So I'm looking at that bracket, and I can see inside I've got x squared minus 49. Now I recognise that to be the difference of two squares. Okay, and the difference of two squares says if I've got x squared minus a squared, then that is going to be x plus a, x minus a when I factorise it out. Okay, so that's what's going to happen here. I'm going to get x, open brackets, x plus the root of 49, which is x plus 7, times x minus 7. Okay, yeah, that's just the difference of two squares. Once you've done it a few times, they're pretty easy to spot. So now I've got three factors, x, x plus 7, and x minus 7. Cool. Question 22, factorise 25a squared minus b squared. Okay, so this is what we call a difference of two squares, and that factorises into two brackets. So the first, at the front of each bracket, you're going to get the square root of the first term. The first term is 25a squared. Now if I square root that, that's going to be 5a, isn't it? 5a times 5a is for 25a squared. So 5a goes at the front. And then the square root of b squared is going to go at the back of each bracket. Square root of b squared is just simply b. And then one of my brackets is going to be plus, and one of my brackets is going to be minus. Okay? Difference of two squares, easy squeezy. Question 22. Write x squared minus 10x plus 29 in the form x minus a all squared plus b. In other words, we've been given a quadratic expression and we're going to have to write it in completed square form. Now, converting a quadratic expression into completed square form, you need to be looking firstly at this coefficient of x. What you have to do is halve that, so we're going to have minus 5. So I'm going to write x minus 5 all squared. Now, x minus 5 all squared is actually x squared minus 10x plus 25. So I've introduced 25 more than I should have. So I'm going to subtract that off again. So I've got x minus 5 all squared minus 25 plus 29. So that is x minus 5 all squared plus 4. 22b, a sketch of y equals x squared plus cx plus d is shown. The turning point is 3, 5. And then we're asked to work out what the values of c and d are. So this is basically a very similar question, but we're working backwards this time. So you should know that if you have a turning point with coordinates a and b, then the equation of the quadratic in completed square form is going to be x minus that a coordinate all squared plus the b coordinate. Well, so in this case, a is 3, b is 5. So in completed square form, this equation is x minus 3 all squared plus 5. Okay, now we want to write it in quadratic form. So basically we just need to multiply out that bracket now. So x minus 3 plus 5. So doing FOIL on that bracket gives me x squared minus 3x plus 9 plus my 5 from before. So that's x squared minus 6x plus 14. So what are my values of c and d? C is minus 6 and d is 14. C is minus 6 and d is 14. Question 22a. We're asked to write x squared plus 6x plus 10 in the form of x plus a all squared plus b. In other words, we need to complete the square. So in order to complete the square, the first step is to take this number here, the coefficient of x, and halve it. So half of 6 is 3. So I can then rewrite the first two terms, x squared plus 6x, as x plus 3 all squared. I then need to take off a square of this number here, otherwise they won't actually be equivalent. So that'd be minus 3 squared, which is 9. And then I've got the plus 10 to add on. So I haven't dealt with that yet. So I get x plus 3 all squared minus 9 plus 10 is plus 1. Okay, so our value of a is 3 and our value of b is 1. 22b says, hence write down the coordinates of the turning point of the curve y equals x squared plus 6x plus 10. Now you notice that's the same expression as we had in part A. Now, if I have an equation of the form y equals x minus a all squared plus b, then that will have a turning point of AB. So that would be the point there on the graph. So here we worked out our equation in complete square form was x plus 3 all squared plus 1. So here we're going to have y equals x plus 3 all squared plus 1. So you can see our value of a is going to be, well, the flip side of that is going to be minus 3. And our value of b is going to be 1. So a equals minus 3. And b is equal to 1, like that. Question 23, factorise 3x squared minus 16x minus 12. Now this is one of the harder types of factorisation because you've got a number in front of your x squared term here. Okay, so I know it's going to factorise if it does into two brackets like this. One of them is going to be 3x and one of them is going to be x, because there's only one way of getting 3x squared out of two things, and if it's that way round. Okay, now the number on the end is minus 12. So let's consider what the factor pairs of 12 are. These are the possible candidates then for the other two places. So I'm going to get 1 and 12, 2 and 6, or 3 and 4. So it's going to be one of those pairs that needs to go in here. Okay. Now it's negative in the middle and negative at the end. That means that one of my brackets needs to be positive and one is negative. But I can't put it in just yet because I don't know if it's that one that's positive and that one is negative, or the other way around, if it's if it's that one and that one. So I can't put them in just yet. I just need to think about which combination is going to deliver me that minus 16 in the middle and where the signs need to go. Okay, so minus negative 16, so it's quite a big negative number. And remember, whatever I put here in this position gets multiplied by the 3x in terms of creating the 16x term. Okay, so probably I want to put the bigger thing on the right hand side so I can scale it up enough so I end up with 16 in the middle, which is quite a lot. Okay, so just try a few different combinations. That's normally the best way of going about it. Now if I've got like 1 and 12 here, that's going to be too much because 3x times 12 is 36, and then when I take the 1 away it's not going to give me 16, so that combination isn't going to work. So what about the next pair, 2 and 6? So if I put the 2 here and the 6 here, then 3x times 6 is going to give me 18x, and 2 times x is going to be 2x, and if I took 2x away from 18x I would get 16x, wouldn't I? Okay, so I think what I'm going to have to do here is going to put the minus sign in there. So the 3x times the minus 6x is going to give me minus 18x, and if I put the plus sign in here, that's going to give me positive 2x in the middle, and then that is going to give me minus 16x altogether. Okay, so it's that way around. 3x plus 2, x minus 6. Now some people teach this in a more complicated way. I don't. I just think it's a matter of trying all the combinations until you find one that fits. I do find those other methods overly complicated. I just try one pair number, and if it works, good. If it doesn't, go on to the next. You can see there's not that many possible combinations, only 3 combinations. So you just try one until you find one that fits. Question 23, factorise 3x squared minus 16x minus 12. Now this is one of the harder types of factorisation because you've got a number in front of your x squared term here. Okay, so I know it's going to factorise, if it does, into 2 brackets like this. One of them is going to be 3x and one of them is going to be x, because there's only one way of getting 3x squared out of 2 things, and if it's that way around. Okay, now the number on the end is minus 12. So let's consider what the factor pairs of 12 are. These are the possible candidates then for the other 2 places. So I'm going to get 1 and 12, 2 and 6, or 3 and 4. So it's going to be one of those pairs that needs to go in here. Okay. Now it's negative in the middle and negative at the end. That means that one of my brackets needs to be positive and one is negative. But I can't put it in just yet because I don't know if it's that one that's positive and that one is negative, or the other way around, if it's that one and that one. So I can't put them in just yet. I just need to think about which combination is going to deliver me that minus 16 in the middle and where the signs need to go. Okay, so minus negative 16, so it's quite a big negative number. And remember, whatever I put here in this position gets multiplied by the 3x in terms of creating the 16x term. Okay, so probably I want to put the bigger thing on the right hand side so I can scale it up enough so I end up with 16 in the middle, which is quite a lot. Okay, so just try a few different combinations. That's normally the best way of going about it. Now if I've got like 1 and 12 here, that's going to be too much because 3x times 12 is 36, and then when I take the 1 away it's not going to give me 16, so that combination isn't going to work. So what about the next pair, 2 and 6? So if I put the 2 here and the 6 here, then 3x times 6 is going to give me 18x, and 2 times x is going to be 2x, and if I took 2x away from 18x I would get 16x, wouldn't I? Okay, so I think what I'm going to have to do here is going to put the minus sign in there. So the 3x times the minus 6x is going to give me minus 18x, and if I put the plus sign in here, that's going to give me positive 2x in the middle, and then that is going to give me minus 16x altogether. Okay, so it's that way around. 3x plus 2, x minus 6. Now some people teach this in a more complicated way. I don't. I just think it's a matter of trying all the combinations until you find one that fits. I do find those other methods overly complicated. I just try one pair number, and if it works, good. If it doesn't, go on to the next. You can see there's not that many possible combinations, only 3 combinations. So you just try one until you find one that fits. Question 26. A curve has equation y equals 4x squared plus 5x plus 3. A line has equation y is equal to x plus 2. Show that the curve and the line have exactly one point of intersection. Do not use a graphical method. Okay. Well, I am going to quickly use a graphical method just to illustrate the point. If you've got, well, the first one is clearly a quadratic curve, isn't it? So it's like a parabola. And the second graph is an equation of a straight line. So either your equation of your straight line is going to kind of skewer your parabola in 2 places, in which case you will have 2 solutions, 2 points of intersection, or your parabola and your line are just going to touch like that, in which case you have 1 point of intersection, or your parabola and your line totally miss each other like that, in which case there are no solutions. So we are assuming then, or wanting to show, that it's this scenario there, that there's just one solution. But we're not allowed to do it graphically. We're going to have to do it algebraically. Okay, so we want to basically solve these simultaneously, which is very easy to do because this is in terms of y and this is in terms of y, so we can just substitute one inside the other. So this is equation 1, this is equation 2, and we're going to substitute equation 2 into equation 1. So we're going to start with equation 1, 4x squared plus 5x plus 3, and we're going to sub in for y is equal to x plus 2. So we're just going to connect them where the y's are. Okay, so 4x squared plus 5x plus 3 is equal to x plus 2. Okay, taking x away from both sides. So if I subtract x from here and subtract x from here, I'm going to get 4x squared plus 4x plus 3 is equal to 2, but I'm also going to subtract 2 from both sides. Okay, and that's going to leave me with 4x squared plus 4x plus 1 is equal to 0. Okay, collecting everything on one side, that is. So I've got 4x squared plus 4x plus 1 is equal to 0. I want to now factorize if possible. So I've got a 4x at the beginning, a 4x squared at the beginning, and I've got a 1 at the end. Okay, so that must be a 1 and a 1, because I can only multiply 1 with 1 to get 1. Now, I could have 4x and x in here, or I might have 2x and 2x. 2x times 2x is also 4x squared. I'm suspecting it's this one because I'm expecting there to be a repeated root. If I got 2x times 1, that gives me 2x, and 1 times 2x is going to give me 4x, so that is actually the solution, isn't it? It's 2x plus 1, 2x plus 1. In other words, you've got 2x plus 1 all squared is equal to 0. So when is 2x plus 1 equal to 0? It's equal to 0 when x equals minus a half. So we've got a repeated root here with one solution. X equals minus a half. So therefore, one solution only. Oops, can't spell only. Only x equals minus a half. Job done. Question 27a. Joe wants to work out the solutions of x squared plus 3x minus 5 is equal to 0. She says the solutions cannot be worked out because x squared plus 3x minus 5 does not factorize to a form of x plus a, x plus b, where a and b are 2 integers. Is she correct? Well, she's right insofar as it doesn't factorize, does it? I mean, if you look at minus 5, then the only factor pairs for minus 5 you're going to get are 1 and minus 5, or minus 1 and 5, and neither of those pairs adds up to 3. So it's not going to factorize, but that doesn't necessarily mean that there are no solutions. and you should all know that if you can't factorize, then plan B is to use the formula, which is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we can only say, well, I mean, the only way that that wouldn't work out is if the determinant part here is less than 0. So if that part there is a negative number, then we've got a problem. Then we can't find any solutions. But is that the case here? What is b squared minus 4ac? B squared minus 4ac, is that a positive number? B is 3, isn't it? So that is 3 squared. 3 squared minus 4 times 1 times minus 5. So, which is 9 subtract 4 times negative 5 is plus, isn't it? 9 plus 20, which is 29. So that means you could evaluate it then, because you could find the square root of 29, and then you can add and subtract that from minus b divided by 2a and get 2 solutions. So as long as this determinant part, this b squared minus 4ac, is a positive value or 0, you are going to get solutions. So you're not going to get nice solutions, that's why it doesn't factorize, but you are going to get solutions. So as b squared minus 4ac is greater than 0, there are solutions which you could find with the formula. Now notice it isn't actually asking me to find them. I just need to give a reason. So is she correct? No, she's not correct. Right, without expanding any brackets, show how to work out the exact solutions of a 9 lots of x plus 3 all squared equals 4. Okay, so how would we work this out without expanding any brackets? Well, rather than expanding the brackets, we can first of all divide by 9. So we'll take the 9 lots of x plus 3 all squared equals 4. First, let's cross multiply that 9 to the other side. So we're going to get x plus 3 all squared equals 4/9. Then if we root both sides, take the square root of x plus 3 all squared, I'm going to get x plus 3. And square root the other side, then it's going to be plus or minus. Square root of 4 is 2, square root of 9 is 3, it's going to be plus or minus 2/3. And then take the 3 to the other side, I'm going to get x equals minus 3 plus or minus 2/3 as a solution. So what are the solutions then? I'm going to get 1 when I add 2/3 to minus 3, and 1 when I take 2/3 away from minus 3. So x is going to be equal to minus 3 minus 2/3, which is minus 3 2/3, or x equals minus 3 plus 2/3, which is going to be minus 2 1/3. Question 29. The equation of the curve y equals x squared minus 18x plus 70. By completing the square, work out the coordinates of the turning point. You must show your working. Okay. Now, when you complete the square, you're going to be replacing the first 2 terms of your expression with something that looks like this: x minus something all squared. Now, that number that you minus happens to always be half of this value here. So for half of 18, I'm going to get 9. Okay, because x minus 9 all squared is going to give you x squared minus 18x plus 81 actually, so we need to take that extra 81 away. So we're replacing x squared minus 18x with x minus 9 all squared minus 81. Now that plus 70 that was there still needs to be written on the end. It's still on the end, it's there. Okay, so this bit that I've written down here replaces the first 2 terms. the yellow bit up there, and then we've still got the last term to deal with, so we kind of add it on the end. All right? Right, so then let's just tidy that up. So that gives me x minus 9 all squared minus 81 plus 70 is minus 11. Okay, so that is my equation in completed square form. Right, now this value here, or this equation here, has its lowest value when this squared part of it is 0, because square number, when you square something, you always get something positive unless you put 0 into it, in which case you get 0. Okay, so the lowest value that any positive thing can take is 0, and that occurs when x is equal to that number there, isn't it? When x is 9. So when x is 9, I'm going to get x minus 9 is 0, 0 squared. So that first term is going to disappear, and it will leave me with negative 11, which is why the turning point is going to be at 9, negative 11, like that. Okay, because it occurs when x is 9. And then if you put x is 9 into that expression, you're going to get minus 11 out. Okay, that's it. Turning point 9 minus 11. That was a very easy last question. And we're done with the paper. Huzzah. Question 29. Solve 5 over 4x plus 1 is equal to 2x over x squared plus 3. Okay, now the first thing I'm going to do is cross multiply these. So this is going to end up here. This is going to end up here. Why? Because I'm going to multiply both sides by the things that are on the bottom. They'll cancel on one side, reappear on the other. Okay, so what you'll end up with is 5 lots of the denominator that was on the right, x squared plus 3, is equal to 2x times the denominator that was on the left, which is that. Okay, removing the brackets, 5x squared plus 15. That is equal to 2x times 4. 4x is 8x squared plus 2x. Okay, going to collect everything on one side. I think I'm going to move it over to the right, so I keep my x squareds positive. So taking 5x from both sides, I'm going to end up with 3x squared plus 2x. Taking 15 from both sides, I'm going to end up with that, aren't I? So 0 equals 3x squared plus 2x minus 15. Okay, now we want to solve it, so we're going to well, it's asking us to show our answers to 3 significant figures, so I'm assuming I cannot factorize here, so I'm not going to bother trying. I'm just going to break out the quadratic formula and try and solve it that way. Okay, so what my values of a, b and c then, a is going to be my coefficient of x squared, it's going to be 3. B is going to be 2. C is going to be minus 15. Okay, so subbing that into the quadratic formula, x equals minus b plus or minus the root of b squared minus 4ac all over 2a. Subbing in minus b minus 2 plus or minus the square root of b squared, 2 squared minus 4 lots of a, which is 3, times c, which is minus 15, all over 2 lots of 3. What's that? That's minus 2 plus or minus. I'm going to get 4 minus negative, what's that? 4 times 3 is 12. 12 times 15 is 180. So it's going to be plus 180. 4 plus 180 is 184, so it's going to be 184 over 6. So minus 2 plus or minus the root of 184 all over 6. So that's going to be then that x is equal to, let's type that into the calculator, negative 2 plus the root of 184 all divided by 6. I make that 1.927 to 3 significant figures, 1.93, or just going to press the back button and change my plus to a minus and press equals. That comes out to be minus 2.59, or x equals minus 2.59. Okay, I think we're done. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.